Alright, today I'm going to teach you how to find the volume of the solid bounded between y equals x squared, x equals 2, and y equals 0, rotated around the x-axis. So first, we're going to need the equation of delta v equals pi r squared. From this equation, we can find the integral from 2 to 0, with the pi there, and the x squared squared.
So I think you're doing it wrong because you have 2 to 0, and that would give you a negative volume. So you have to go from 0 to 2. So change it.
I think you're confused. See, I'm teaching this.
Well, no, you clearly have it wrong. Here, give me a marker.
No, you do not get the marker.
Give me the
Only
marker.
the teacher gets the marker.
Give me the
No,
marker.
no.
How is Mark sleeping through all this?
Mr. Breeze thought it would be a good idea to have the students teach each other AP Calculus practice questions, which is a good idea. I think Sean might be taking it too far.
You're useless, weak, extra. Tienes ganas.
Sean thinks he's Jaime Escalante. He spends the majority of his time yelling obscenities at us in Spanish.
Tú eres un pepino del mar. No haces nada. Tienes gana.
Translation: You are like a sea cucumber. You lie there and do nothing. He was talking to Mark. He's not wrong.
So, can you explain this to me?
Yeah. So, we want to find the volume of the object formed by this base revolved around the x-axis. This base is formed between the line y equals x squared and y equals 2x. So we're going to take pi times the integral from 0 to 2, because this is where these intersect, of our top function, 2x squared, minus our bottom function, which is x squared. And we're going to square that. And we're going to take it in terms of x. Okay? Now, because of where this is on the AP test, we can use our calculator, and so for time, we're going to use a calculator to solve for this. So we're going to take pi times the integral from 0 to 2 of 2x, I don't know why that's capitalized, but hopefully it works, minus x squared dx. And we get 13.4. So the area of this volume, it's going to be 13.4.
I'm actually really smart. You could ask me any math problem and I'd be like blah blah blah, x squared, y squared, whatever. There's your answer.
Mary's okay at math once she's not sleeping. I have to explain a concept to her a minimum of 27 times because she's always so spaced out. I think the only reason she passes tests is because she copies off Katie's notes.
What? She takes pretty detailed notes.
Yeah, I take notes.
Alright, we're gonna try this again. In order to find the volume, you must subtract the bottom from the top. And since it's in terms of x, the bounds are gonna be...
No, look, you gotta take a slice. We've
Jack.
already gone over this. No, we've already gone over
Jack,
this. Take a slice.
I'm the teacher.
No, tienes ganas?
Don't you ever say that to me.
What are you gonna do?
I know 7 types of jujitsu.
Oh, okay, so obviously the only way to solve this is a fight to the death.
That's not fair. For Jack.
Fine, we'll do a teaching competition. Whoever can teach question 5 better is the better teacher.
Fine. Fact. My brain is faster than a calculator. Therefore, I will win.
Oh yeah? What's e to the natural log of 65?
27.
Wait, I didn't know we had a calculator.
We don't.
Welcome to the opening day of the Teaching Olympics. Sean will teach first. Jack was asked to leave.
So, in the spirit of fairness, I have to leave. But that's not going to stop me from collecting reconnaissance.
Alright, so what you want to do is take the integral from 0 to 2. Okay, so as you can see from this equation right here, you can find the answer to this problem, and so I have successfully taught this. Jack, what are you doing? Jack, it's not your turn.
Yeah, I think it is. Alright. Alright.
Jack.
Fine. You can discuss it over there. Yeah. Alright.
Okay.
So we really have -6 to 2. So what that means is like point A to point B. So this is -6, point A, and this is 2. This is -6. This is 2. Oh, I dropped my pencil. This is -6. This is 2. So what that means is, well, that's really just where the graph is going. I don't really understand it. Hold on, Mark. I'm trying to explain something.
There's an
so,
easier way to do this.
do you want to teach? Do you want to teach this? Do you think you can teach this?
Yes, I can.
Go fetch, you ignorant slug. I'm so done with this. What am I doing? I'm running away from my responsibilities. And it feels good. I kind of knew what I was doing when I was teaching, but in a much more real sense, I had no idea what I was doing.
I don't understand why Katie started this competition in the first place. I mean, finding the area underneath the curve isn't that difficult. You can use integration, left or right hand Riemann sums, the trapezoid or midpoint rule.
Wait, can you actually do math?
Of course I can do math. I just don't because I think it's funny to watch Brian get all red and anxious trying to teach me. It's my only source of fun around here.
So Mary, do you understand the concept now?
No, I'm just as confused as I was before. So who wins?
I guess no one wins.
Well, what do we do now?
Well, we've survived this long with a teacher that can't teach. We'll be fine.
Welcome back. In this presentation, I actually want to show you how we can use the antiderivative to figure out the area under a curve. And hopefully, actually I'm going to focus more a little bit on the intuition.